What's going on, everybody? This is Future Automation, a place where imagination meets reality, and you're listening to Tejas. So, guys, in this video, what we are going to do is we are going to take a look at another sensor module, which is DHT11, which is a temperature and humidity sensor. So, with a cup of coffee, let's get started. So, guys, this video is going to be a little bit exciting because in this we are going to do a little bit of actual IoT where we are going to push the data over the internet and then take a look at the chart visualization and all that stuff. Although that is not going to be a full-fledged code explanation and all, but I will give you a demo of that at the end of the video. So stick in the video and let's move ahead. So before going into the coding part and the technical specifications of the sensor, let's see how the sensor is actually made, what is the physical appearance of the sensor, and then we'll go slowly into the technical information about the sensor. So this is the DHT11 sensor, guys, and it's temperature and humidity sensor. So we get temperature in both Fahrenheit and degree Celsius, and we get humidity in percentage. So the main sensor actually is this one, which has four pins. So let me try to zoom in a little bit more. Okay, cool. So you can see that we have four pins here, but the module here is having only three pins, and they are very simple. So one pin we have is ground, the second one is VCC, and the third one is the data pin. So we connect the data pin to a digital pin, VCC to 5 volts, and then ground to ground. Now, uh, if we are going to the actual data sheet, then the information provided for this sensor is that its power supply varies from 3.5 volts to 5.5 volts, and then it gives you temperature and humidity data through serial data, and it can measure a range of temperature from 0 degrees Celsius to 50 degrees Celsius, and humidity goes from 20% to 90 with a plus minus accuracy of 1%, and 1 degree Celsius is what they have provided on the most of the websites. But with my own experience, what I think is that we can go and consider, sorry, we can consider an accuracy of around 2 to 3 degrees Celsius and 2 to 3 percent of humidity. So you can take that in mind based on what I have experienced. Moving on, now let's go to the code. In code, it's also very straightforward. We have only one library that we are going to include, that is dht.h. Now, this is DHT11 sensor. We have different sensors as well. We have DHT22 as well. Then we have few more sensors. Now, where that comes in picture, I'll show you in a minute. So we are going to define two more micros here. One is DHT pin, which is we are going to connect to pin number 2. Then we have DHT type, and here we have to specify which type of DHT sensor that is. So we have DHT11, we have DHT22, then we have few more, but yeah, we are going to use DHT11 as of now. Then we are going to create an instance of that by passing in the pin number to which the DHT11 sensor is connected, and then the type of the DHT sensor, and then we are going to use that instance in the coming upcoming code. Now in that, we'll in wide setup, there's very simple two-line code, that is, will begin serial begin of 9600. And why that we are going to do other than serial monitor, I'll explain you in some time. And then we are going to do a DHT begin as well. Now most of the code is in in the while loop, so let's go to it. We are going to give a delay of 2000 seconds, and then we are going to move towards reading the data. Now make sure that you give a little bit of delay, because reading data from sensor also takes some time. So if you don't give delay, sometimes there will be an error in the sense of data that is being read. So you need to make sure that you give sufficient amount of delay while working with that. Now one by one we start reading the data. So first we are going to read the humidity with read humidity function. Then we are going to read temperature, and then we are going to again read the temperature, but here we are passing a boolean value true. So here we'll be reading the temperature in degree Celsius, that is when we don't pass anything, and when we pass something, that is when we need to read in Fahrenheit. So if we want to read in Fahrenheit, we are passing true, and then we'll get the Fahrenheit. Now, why we need Fahrenheit, that also we are going to see in a minute. So stay focused a little bit and keep an eye on the code so that you'll get an idea here. Now, all the people who are new to this particular video or this series, make sure you go back and check the previous videos as well, because getting from the basics, it will be a bit easier to go through this, because those who have watched the previous video, for them this code is not that complicated. Other than the functions that we are using, most of the things like void setup, void loop, serial begin, those are pretty straightforward, so nothing too much of a complication for them. But those who are new, they can go ahead and check out the previous videos. Next to that, now we are going to check here if a reading of data has been failed at any point. So if any of the data that we read, if it is failing, then we'll give a failed to read from DST sensor serial print. And if not, then we'll continue ahead. Now, here you can see that there's another one variable which is referring to heat index. So basically heat index here is something that before, so moving to the code, let me just explain you what is heat index. So I have found out something on internet, and even because even I was not aware what was heat index, so I need to take a look at it. So this is the definition on Wikipedia, but in a summarized form, what it is saying in a one liner is that actual temperature that the human body is experiencing is what we call as a heat index. Now, this heat index is a combination of air temperature and relative humidity. Now, that temperature will have to send in Fahrenheit, and that's why we read the Fahrenheit value as well. Because here, compute heat index, we are passing Fahrenheit and humidity, and we are calculating the heat index. So that is the temperature that human body might be experiencing relative to what temperature we are having in the surrounding. Now I have created one, so I was testing it, in a different form of how we can display it in serial print. But I skipped this part. I have commented that out. Why? That I'll explain you again in a minute. And this is how we are going to print it serially. And basically that's it for the code. Now, why I have done it in this way, where we have, data separated with comma and all that, I'll explain you once we run the code. And then same thing, what we are printing here, this data is going to be used in that final project, which I'm going to show you, the IoT project. So let's move on to burning the code, connecting the sensor to the Arduino, and then, reading the data and showing it off on the serial monitor and plotter. Okay, guys. So as you have seen in the code, we are supposed to connect the DHT11 data pin to pin number 2. So let's start with that. Uh, I hope that you guys are able to see it. So this is the data pin that we are going to connect to pin number 2. So 0, 1, 2. Make sure you don't mess up the pins. Stay alert what you're connecting. Second is the middle pin, that is to VCC. So V in ground 5 volts. This is the VCC. And then the final pin will be ground. So you can connect to any of the second or the third pin in this line for Arduino. And yeah, I think this is it for the connection. So let's connect Arduino. Okay. I've connected the Arduino. I'll burn the code here, and let's bring up the serial monitor. Okay, the code is uploaded. Let's see if we are able to read the data now. And yeah, that's it, guys. So we are reading the data here. Humidity is around 66%, temperature is around 29, and we have the degree Fahrenheit to around 84.20, 83.66. So slowly the temperature is reducing. It's kind of cold here. and you can consider that 2 to 3 degrees Celsius of accuracy plus minus, and you can calculate the temperature. So that's about it for the quick demo of how to connect the sensor. But if it's really working or not, that I'll show you now. Okay, guys. So before starting this demo, a disclaimer, a notice, warning, whatever you consider. Don't do this at home if you don't have any expert guidance, any seniors guidance. If you are a small kid who is trying to play around with this from school, don't try this at home. Make sure you have someone to help you out with this. That's a request as well. Now, what we are going to do is I'm going to match a light matches here, and let's see if temperature rises. So let me catch this a little bit above and try to heat it up a little bit. Make sure you don't take it too close because I have damaged 2 3 sensors in this trial, not now but in previous times. So because the top the front part is of plastic, so you can see that it has burned already. Now it's hot, so hopefully it should read something. I'm not sure whether it is reading or not. Okay, it is reading, but I forgot to. Yeah, you can see here that the temperature has rose to around 54 degrees Celsius. I I forgot to scroll down.
ठीक है.
So you can see that. I think how we are supposed to automatically go down. Not sure, but it usually goes down like this. So you can see that the temperature has rose to almost 54 degree, and Fahrenheit is 129.56. Heat index goes around 108. Humidity is almost to zero now. Now, if we'll wait for a while, slowly the temperature will start, you know, reducing because the surrounding is quite cold, and humidity will start getting add up. Now, this sensor is only calculating to a certain, radius. It's not like it is going to calculate for a very huge amount of radius. So the temperature value will start reducing gradually. And you can see that we have reached to almost 42 now. And so what the idea here was that why I presented the values in that format was because of this. So the comma separated values and all that. The reason is because I wanted to show you guys this, uh, the serial plotter, because that is very interesting. Now you can see that I didn't mention anything different to show everything on the serial plotter, because it is smart enough that it will get the values and the titles of the values based on the comma separation and all that. So I have presented the data in this manner. You can see that we have the title, then we have the value, and then we have the comma. So based on that, it is identifying what exactly is the value, and you can see that it is decreasing as well. So that's what I wanted to show you. And don't try this at home. This is a humble request, a warning, what you can consider. Do not try this at home. You can see that slowly the temperature here is reducing, the humidity is increasing. It's almost about around 40ish, and we have the degree Celsius, which is way down to around 35 to 30 in between, and so is the degree Fahrenheit and the heat index. So that's what it is, and now it's time for us to do that actual IoT application. So guys, okay, now to work with this IoT application, I have revisited one of the old project that I had worked on in a long time back then, which is related to putting the data to think speak. So this is one of the IoT platform which is having a really great way to start with IoT if you don't have any prior experience. It's pretty simple. How to set up and all, we are going to take a look at in another video where I'm going to do it. If you want this code, you are already aware, or if you want to start playing around, I have already added the code in the GitHub where the Arduino code is also already available in the same repository. I'll leave the link in the description, but take a look at this. It's very quite interesting and it might, uh, make you a little bit curious. So I'm not going to go into too much of a code, but one thing I'll let you know that what we are going to do is the setup will be same right now what we have done a few minutes back for reading the temperature and humidity sensor in Arduino. It's same code, everything is running same. Just the difference is instead of reading the data and showing it in serial monitor, we are going to keep everything closed, and we are going to take that serial data and pull it in Python and use that data and push that data in the ThinkSpeak. That's what we are going to do here. So let's execute the code directly and see if things are really going to work. So last data you can see here, that last entry was around about 23 hours ago, 2 days ago. So I created the video at that time, but somehow the audio didn't got recorded, so I'm doing it second time, and my bad for that. So let's run the code, and we have an error. So let me just check what's going on. At which the port is red. Okay, what it is saying is something of a mess. COM3 port is connected. Serial monitor is not on. Arduino is connected. Everything is fine. 9600 COM3. I think Arduino is connected to same COM3 only. Yeah, it's connected. So let's clear it again. Access denied. This is strange. Let's try it one more time. Okay, so we are getting the data. So sometimes it happens, you go back to the Arduino, you open the serial monitor and then close it back, or just remove the Arduino pin and reconnect it, and probably it should work in some cases, but most of the time you should check the COM port and all that things. Since we have already worked with Arduino code and we have burned it, it should work. So there was no issue of COM port, that was for sure. Now you can see here that it has started pushing the data less than a minute ago, and you can see that uh, okay, it was created, this channel was created 2 3 days ago, but I last recorded the video yesterday evening, my bad again. So you can see that it is pushing the data now, and we can read the data as well. So here we have the humidity at around 60, temperature is at around 28. So from around 454 it got back to around 28 27 now, and Fahrenheit is around at 83. So we want to see the spike, so I'm going to do that part of lighting up the matches and do it again, although it's not being shown on the camera. But what I did a while back, the same thing I'm doing right now. Do not try this at home again. If you are small and you don't have any experience, please do not try it at home. Let me just heat it up. Hopefully I will not damage the sensor. Okay, so we should get the values in some time. It takes some times to heat up. Now let's see if here we have found out something. So you can see that already the temperature has rose to around 36, 37, 38. So the spikes will be here. So you can see that suddenly the temperature has spiked to around 32 now. Humidity should get reduced now slowly, and the Fahrenheit is at 91. So see, humidity has reduced to 58. Temperature is rising at around, I think, yeah, 38. 38. So you can also export this data in the data into import export. well, we are not going to see that now because uh, I don't want to make too much of a complication for you guys. This particular section of video we are going to cover in future, and we are going to create ourselves such kind of platform which we'll be using to visualize the data, show the data and all that with different sensors, and we are going to have a lot of fun in that. As you have seen in the previous one video, I have bought RPi 5, so I'm really super excited to create this setup video. If you have not seen the unboxing video, go check it out. It's really a fun. I have bought uh, different cool accessories which are officially from RPi, including the cooler case and the power supply and the RPi itself. Awesome, awesome piece of tech, I can say. And yeah, that's it guys. If you like the video, make sure you hit subscribe button. If you're new to the channel, if you are already a subscriber, make sure you like the video, share it with every IoT enthusiast who is interested in creating such projects. If you have any kind of project ideas, queries in any of your project, make sure you hit your queries in the comment box. I'll take a look at it, and I'm always checking the comment section, so make sure if you have any kind of queries, let's get together and fix them. And keep innovating guys. Take care. Thank you.